Greetings YouTube, it's Iron Orange here. In this video, I'll be showing you how to make an enemy move along a predefined path. By the end of this video, you'll have a basic script that you can play with and modify to your liking. Let's get to it, shall we? As you can see, we have a basic Unity 2D project here. The first thing that we're going to do is add a sprite to represent our enemy. So we'll right-click, 2D object, sprites, square, and we'll just name it enemy. And the next thing that we're going to do is create 3 circles to represent the path that we want our enemy to follow. So we'll just go 2D object, sprites, we'll select circle. We can leave it named circle, that's fine since this is just a demo here. And we'll Control D twice. And let's create our path here. We'll go to the first one. Let's make it move left. We'll go to the next one. We'll keep going left. And then the last one, we'll go ahead and move it up. And then we'll go up here. So we're basically wanting our enemy to go from circle 1 to circle 2 and then to circle 3. And then the next thing we're going to do is create a script. And this is basically going to be attached to our enemy game object here. And this is going to make our enemy move from one waypoint to another. So again, from circle 1 to circle 2 to circle 3. So we'll add component. We'll go new script. We'll call this enemy movement. And we'll go ahead and open this up in our code editor after it loads. All right, so we have our Unity script open. We're going to get rid of this start method because we do not need it for this one. Okay, what we're going to need is a container for our different transform positions for our different waypoints. So anytime we're dealing with multiples of a thing, we're going to want to use an array. Well, I shouldn't say anytime, but for this instance we are. So let's go ahead and say public transform, and we'll do our square brackets to represent that this is an array. And let's call this waypoints. And what we're going to see back in Unity, what we're going to see is that we have this nice little waypoints drop down, and we can add as many of these as we want. Now, how do we get our enemy to move to the first waypoint? Let's go ahead and bring up our script again here. So the first thing we need is a reference to the first element or the first waypoint in our transform array. So let's go ahead and create that. We'll create this as a private int. And let's just say current waypoint. Okay, and for now we're just going to leave that as 0. And remember, in coding, our counting always starts with 0. So that's going to be the very first waypoint. Now let's also create a method down here below our update method. We'll call it move towards waypoint. Oh, no, we want our curly brackets there. There we go. Okay, so I'm going to minimize the script, and we'll go back to our Unity engine here, and we're going to add waypoints, and let's add the first element in that array, right? So as you can see, this is a transform. So we'll just take the first circle, which is our waypoint, and then we'll add it to that transform. Right, okay. So there's the transform of circle number 1. And then we're going to add it for the other 2 circles as well while we're down here. So we'll add in our second element. And then our third. All right, let's jump back into our script here. Now, how do we reference the next waypoint that our enemy needs to move to? This could be tricky because we need to go to different waypoints. We're not just going to say go to one waypoint. So what we're going to do is create a variable that will reference the index in a dynamic way. Let me show you what I'm talking about. So we're going to create a variable. It's going to be of data type transform. And again, this is referencing the transform of our waypoints here, or the X and Y. Okay, and we can call this current waypoint. And this is going to be equal to waypoints. Now waypoints again is our transform array up here. Now, what index do we want to set this to? Yeah, you could hard code it, but I think the best option here is to use our variable, current waypoint index, okay? Okay, so we've figured out how to hook into our waypoints here. Now, how do we actually get our enemy to move to the waypoints? Well, lucky for us, Unity has given us a function called move towards. So let's take a look at our handy dandy Unity documentation. And we have this method here for vector 3, vector 4, and vector 2. We're interested in vector 2. And what does it say? Moves a point towards the current target. Now let's drill into this here. And what it wants from us is vector 2 current. Where's our enemy now? Vector 2 target. Where's our enemy going? And then max distance delta. How fast do we want the enemy to move there? Okay. So for this, we're going to go ahead and implement this method. Let's go back to our script. All right, so the first thing that we actually need to do is we need to ask our enemy what its current position is. How do we do that? We go transform dot position. Now we're hooking into the enemy sprite's current position, and we're going to set that equal to our method, which was vector2 dot move towards. Okay, but we need to give this method a few things. We need to take the current position. Where's our enemy now? So for that, it's going to be transform dot position. Where's our enemy going? Well, it's going to the waypoint, right? Now this isn't really a part that we've touched on yet, but we'll go ahead and take care of it now. How fast do we want it to get there? We need another variable up here. All right. And what we're going to do is we're going to call this variable speed. Now speed is going to be a public variable because we want to be able to edit this in Unity and tweak it to our liking. And then the data type is float. We don't want this to just be 1, 2, 3, 4, 5. We want it to be 1.4, 5.7. We want as much flexibility as possible. So we'll set this to float speed. Okay. And we'll just give it a default as 5F for now. We can always change that again in Unity. Okay. So now we're going to set this to speed. Now, when we're moving things in Unity, we don't want it to go according to the update method. That's a whole other topic for a whole other video. So long story short, we're going to go according to time, not frame rate. All right. Because what if one person's computer has a frame rate of 30 and another person's computer has a frame rate of 150? Okay, you can see the issue there. So again, we have our move towards. We're giving it three things. Where is the enemy currently? Where do we want it to go? And how fast do we want it to get there? Okay, so we've figured out how to actually move the enemy. Now what's next is we need to basically tell our script to check if the enemy is at the current waypoint. And if it is at the current waypoint, well, where does it need to go? To the next waypoint, right? So let's take a look at this visually. So we're telling our script to move to the waypoint. Then the next piece that we have to solve through code is we need to say, are you at the waypoint? So, if the enemy is at the waypoint, then the distance from the enemy to the current waypoint is probably going to be pretty small. So now that it's at the waypoint, well, we need to go to the next waypoint, right? We need to go here. But let's not get ahead of ourselves. How do we check the distance between the enemy and the current waypoint to verify that it is at the current waypoint? Okay, so how do we work with distance and hook into that in our code so that we can check things and whatnot? So let me bring over the Unity documentation page, and we're going to drill into our vector 2 here. Well, actually, you can see the fourth option down returns the distance between A and B. Bingo. That sounds like what we need here. Okay. So it's asking two things from us, the distance from A to B. So we're going to need two vector 2s. So let's implement that in our script here. All right, so how do we implement this distance method that seems like it'll be helpful to us? So the first thing we'll do is we'll go ahead and type it out here. Vector2 dot distance. Okay, and we see that we have our red ramen here. So it still needs some stuff from us. And what does it need? It needs the things that we're checking the distance for, right? So we need to check the distance of our player versus our waypoint. What is this? If you can see this white line grid here, we're kind of checking to see like what is the distance between these two, right? So let's do that. So we're going to give it a transform.position. What is the X and Y of our enemy? And the next thing is the X and Y of the waypoint. All right. So Unity is going to take care of the rest for us. It's going to do all the magic. All we need to do is say, here's position 1, where our enemy is currently. Here's position 2, where the waypoint is. And to better understand how this is working, we need to go back to the documentation and look at one critical piece to this. That is, returns the distance between A and B. Keyword returns. What is it returning? It's giving us a float, a 1.2, 3.5, etc. So what we need to do is we basically need to take what this method is returning to us, i.e. the float, and we need to compare it to see what that distance is. Check, is the distance less than, 0.1? Because if it is less than 0.1, well, odds are the enemy is right at the waypoint. How do we do that in code? Let's do it. All right, so I'm going to go ahead and kind of make this into pseudocode first, just so you can really wrap your head around the logic. So let's do this line by line. So you don't have to type this out or anything. This is just pseudocode. We're going to get rid of it when we're done. So we're going to say if the distance that is returned by vector2 I can't even type today. vector2.distance. Now, what was the vector2.distance giving us? Remember, a float. Okay, so let's actually, if the distance that, let's say if the float, that would actually be more accurate. If the float that is returned by vector2.distance is less than, let's say 0.1 f, then we need to do a thing. We'll get to that in a moment, but let's first type this if statement out, okay? So remember, if statements are checking if a thing is true or false. That's all it's doing. So let's go if, and then we'll get our curly braces here. if the float returned to us by vector2.distance, which is this, right? This method. So let's just go ahead and cut that out, paste it in, and get rid of our orphan semicolon here. If the float returned by vector2.distance is less than 0.1f, then we need to do a thing. And so the thing that we're going to do is actually move on to the next waypoint, if there is one. So if you remember, back up here, we had set our current waypoint index to 0, which is pointing at this element 0 here in Unity. So essentially what we're saying is, if we're here, then go on to this next one here, and so on and so forth. Okay? So this is very simple. Probably the easiest thing that we've done so far is we're going to say current waypoint index equals current waypoint index plus 1. All right, so we're taking this and we're essentially changing this to 1, which is going to point to this, and then so on and so forth. But there's a better way to do this that's a little more clean. If this makes more sense to you, then by all means keep this. But what you'll see a lot out in the real world is we'll do something like this. This is kind of a shorthand. We'll say current waypoint index plus plus. Does the exact same thing, just a little less code to deal with. All right, so let's just do a little bit of cleanup here. I said we would get rid of this. You can keep that if that helps you, just going back to this to make sense of it, but I'm going to go ahead and get rid of it and then get rid of these extra lines here just to clean things up a bit. Okay, so now what we need to do is every single frame we need to check. Is the current waypoint that you're at, that the enemy is at, less than the number of waypoints? In other words, if I'm here, well, are there more waypoints? How do we check that? Because if that is true, then we need to go to the next waypoint, and so on and so forth, okay? So how do we check things in code? How do we check if something is true or false? Easy, if statement, all right? So let's do an if statement. We'll make a skeleton for an if statement here. Okay, what are we checking? We want to check if the current waypoint index, meaning is our enemy here, or is it here, or is it here? Okay, so current waypoint index, is it less than the total number of index, or I should say array elements? So, there's 3 array elements here. If the array element or the waypoint that the enemy is on is less than the total number of elements, well, then that means it hasn't reached all the waypoints yet. Okay, so we're going to hook into the array length. Now, that's going to be waypoints, which again, waypoints is our array of transforms, dot length. Now, this dot length has nothing to do with Unity. This is a standard C# array method, and that's going to give us a number, and that number is, you guessed it, the total number of elements in this particular array. Okay? So we also need to do a thing if this turns out to be true. And what is the thing that we're doing? Well, all this work we did just down here, all we got to do is take our method, bam, paste it in there. Don't forget your semicolon. All right, now that's pretty much it for this. But let's just do a quick recap of what we did. So our first line here, this is an array of transforms, aka these guys right here. We have our speed. How fast do we want the enemy to move between the waypoints? All right, and then we basically just have a way to keep track of the waypoint index, 0, 1, 2, so on and so forth. Then we have our standard Unity update method, and we're checking if the current waypoint index that our enemy is on is less than the total number of waypoints, in this case 3. If it is, then move towards the waypoint. Okay. All right, now the first variable that we have here within our method is current waypoint, and that's hooking into the transform of whatever the current waypoint in our array is at. So here is essentially connecting to this variable, one of these guys, one of these transforms. Okay, remember the next thing that we're doing is we're moving our enemy. We're using the magical Unity move towards method. We're giving it the 3 things that it wants us to give it, which are where is our enemy, where is it going, and how fast is it getting there. Now next we're doing some logic. Is this thing true or false? What are we checking if it's true or false? We're comparing essentially 2 numbers. The first number is what our vector2.distance gives us when we feed it our current distance and the position of the current waypoint. Okay, so we're comparing that number to 0.1f. If it is less than that, that means our enemy is on top of our waypoint essentially, and we're increasing our waypoint index. Okay, we're increasing that to 1, to 2, to whatever the next number is. And that's it. Now let's see all this in action. Drum roll, please. Now, if you're putting this in your game, obviously you wouldn't want the circles to be here. This was just more for demonstration, so we can actually, for now, just go ahead and disable these, or not disable them, but remove the sprite render, and that will essentially effectively make them invisible. So we'll go ahead and play this again, just as kind of like a proof of concept that yes, this works. Okay, and there you go. Now you should be able to scale this according to your needs. This is just kind of like a very basic setup to get you going. I hope you enjoyed this video, and if you did, feel free to subscribe and check back for more content later. Thank you.